Good morning, students. Today we want to look at the topic energy. Can we say energy together? Energy. And these are all the subtopics we'll be looking at under energy. What is energy? We'll look at mechanical energy as one of the types of energy or forms of energy that we have. We look at the law of conservation of energy. Energy conversion, that is from one form to another form, and we look at energy transformation by a thrown object. If you throw an object from the top of a building downward, we'll look at how energy is being converted. Then we'll look at past questions in both WAEC and JAM. So let's start with the first concept under energy, which is definition of energy. So what is energy? As students, can you try to define what energy is? I'm very sure we all know the meaning of energy. I will revise with us. Energy, okay, let's write. What is energy? I can say energy is the ability to do what? What did I say? Energy is the ability Energy is the ability to do work. So if I have the strength to do work, it means I possess energy. So invariably, we can say energy and work done have a relationship. The unit of energy is the same thing as the unit of work done, which is joule. Don't forget, capital letter J. So we all know that we have various forms of energy. We have mechanical energy, we have chemical energy, we have solar energy, we have atomic energy, and lots more. The one we'll be particular with is mechanical energy. So let's look at what mechanical energy is all about. Mechanical energy can best be defined as the form of energy that has to do with the position of an object or the movement of an object. What do I mean? Energy possessed by a stationary object or an object placed at a particular position, or energy possessed by an object that is in motion is called mechanical energy. So we now come to the forms of mechanical energy or types of mechanical energy. The first one is potential energy, and the second one is kinetic energy. So let's try to look at potential energy. Potential energy is the energy possessed by an object due to its position. Again, potential energy is the energy possessed by an object due to its position. Let's try to look at this. Let's assume I have a building. This is a building. I place an object on top of this building or on top of a table. Now, this particular object is at a particular position, and we say this object possesses potential energy. It has an energy here, which is what? Potential. So again, potential energy is the energy possessed by an object due to its position. Now, and I told you that energy is similar to work done. What is work done? Work done is the product of force and displacement. I would say product of force and distance moved in the direction of the force. So the same thing, our potential energy of this object will be the force exerted by this object, which will now be the weight of the object multiplied by displacement. Here, the displacement of this object is the height of the building or height of the object. So we say potential energy is the weight of the object multiplied by the height, which is the displacement. So we say potential energy here equals to mass times gravity is weight. The weight of an object is a multiplication of the mass of the object and acceleration due to gravity. So we have times h. So potential energy equals mgh. So the second type of mechanical energy is kinetic energy. What is kinetic energy? Kinetic energy is the energy possessed by an object in motion. If I run from point A to point B, I possess kinetic energy. So, what is now the formula? So we say kinetic energy is the energy possessed by an object in motion. So, what is now kinetic energy? The formula is for an object to move, number one, the object must have a mass. It must be massive, which means the object possesses matter. Then multiply by the velocity. For an object to move, it has to travel a velocity. So half mv squared. So what is the unit of potential energy? And what is the unit of kinetic energy? The unit of potential energy is the same thing as the unit of energy, which is joule. And the unit of kinetic energy is the unit of energy, which is also joule. Don't forget, if you are asked to calculate potential energy or kinetic energy, the answer you get using this formula, you must put capital letter J, which indicates joule. Okay, the next thing we want to look at is law of conservation of energy. This is also called the law of thermodynamics. Anything you conserve, it means you are not losing that thing. That thing is only changing from one form to another. It means that thing is being preserved. So the law of conservation of energy states that energy can neither be created, it is the energy that can neither be created nor destroyed, but can be transformed from one form to another. So this law is also called the law of what? Thermodynamics. It states that energy can neither be created. Look at the energy of the sun. We are not creating it. Look at the energy that we get from electricity. That electricity or the electrical energy is gotten from somewhere. We did not create it. So it can neither be created nor destroyed. For example, I want to switch on my generator. I put fuel in the generator. After 5 hours, the fuel disappeared. Did I destroy the fuel? No. The fuel is being converted to electrical energy. So I did not destroy it. So the law is very simple. It's what we all know. Energy can neither be created nor destroyed, but can be transformed from one form to another. And the law is also called the law of thermodynamics. Okay, let's look at the next thing under energy. We want to look at energy conversion by different instruments. Say energy conversion. Now, what's the meaning of energy conversion? The energy conversion is also talking about the law of thermodynamics. That is law of conservation of energy. For example, if you have a photocell is an instrument that converts light energy into electrical energy. You can see photo. Photo means light. Cell means a device that generates electrical energy. That's your normal battery is a cell. So we have photocell. It converts light to electrical energy. Your pressing iron converts. For you to use your pressing iron, you need to plug it into the power supply. So which means you are converting electrical energy to heat energy. Electrical to heat. Number 3. Now, your generator, or we call it a dynamo, it converts mechanical energy to electrical energy. So we have all other instruments that convert energy from one form to another. And the last thing we want to look at for today before we solve our questions in WAEC and JAM is to look at the energy conversion by a thrown object. Let's assume that I have an object on top of this building or cliff. I have an object here. Now, how is energy converted from this top of the cliff? If I throw the object downward towards this bottom, how is energy conversion? So, at the top of this cliff or building, this particular object possesses a particular energy. I want you to guess that energy between kinetic energy and potential energy. I'm very sure you can still recall what we have learned under the types of mechanical energy. The energy possessed by this object is actually potential energy. So at the top of this clip here, we have the object possessing entirely potential energy, and it has no kinetic energy. It has no kinetic energy. Now, so that is the energy possessed by the object at the top of this building. Now, if I throw the object, let's say the height of this building is 10 meters, for example. So here I can calculate the potential energy of this object by saying the mass of the object multiplied by gravity, which is 10, and multiplied by the height. So I can get the value for potential energy. But do I know the velocity of this object? No, it is not moving. So I cannot get the kinetic energy. So the kinetic energy is 0. So let me now throw the object downward. This is the midpoint. Let's say this is 5 meters. If I throw the object downward, what happens? The potential energy will reduce. How? As the object is moving, let's say it's at this point. Don't forget this is all 10. This is the bottom here will be 0, 5, 6, 7. So at this place, let's say the height of the building is reduced to like 7 meters. So definitely, if the height from 10 is reduced to 7, definitely the answer for my potential energy will reduce. So which means as the object is coming down, the potential energy of the object reduces. Then what happens to the kinetic energy? The kinetic energy increases. The kinetic energy, how? Because the body now has a velocity. So we can calculate the kinetic energy as half mv squared. So at the midpoint, which is the 5 meter point, what happens? The object will possess half of the potential energy, which means the potential energy will be divided into 2. And the body will possess half of the kinetic energy here. Another thing you need to note is that at the midpoint here, the potential energy, which is half of the entire potential energy, will be equal to the kinetic energy here, which is half of the entire kinetic energy. So as the object moves, continue to move downward, what happens? The potential energy continue to reduce and the kinetic energy continue to increase. Just before it hits the ground at this point, just before it hits the ground, just very little amount of time before it hits the ground, potential energy has drastically reduced, almost going to zero. So the potential energy will be converted to kinetic energy. Again, just before it hits the ground or the floor, the potential energy will be converted to what? To kinetic energy, which means the object will have a maximum kinetic energy. So here, the gist here or the hint here is that anytime you hear from a question that the object is about to hit the ground, you should know that the potential energy is being converted to kinetic energy. So if you are not giving some values for kinetic energy, you can use the value for potential energy, which is mass and gravity and height, to calculate kinetic energy, because at that point, the two are equal. Please take note of that. Now, when the object now hits the floor, don't forget the potential energy is gone again, converted to kinetic energy, and because the object is now stable, no more movement, the kinetic energy will now also be converted to potential again, and the potential energy will be converted to sound energy. Sound energy. So thank you very much. I believe I have done justice to this topic. In the next class, we are going to look at some past questions. Thank you very much.